my name is Suhani, and this is my Physics 2211 Lab 3. So, the purpose of this lab is to find the mass of a black hole by calculating the force on a star at multiple points. The purpose of the second part is to create a trajectory of a ship around a gravity of a planet and a moon. A brief synopsis of the findings of the lab was that the black hole had a mass of 8.71 to the times 10 to the 33 kilograms, and the relationship between rate of change of momentum and F-net was found. Some basic physics principles and models in this lab were parallel and perpendicular components, universal gravitational forces, position and velocity update formulas, and Newton's second law of motion. This lab was modeled solely through GlowScript code. Some main physics ideas, as before, are parallel and perpendicular forces. As in here, you can see that the sum of the parallel and perpendicular component in momentum is the same as the respective ones in parallel component of the net force and perpendicular component of the net force. So they are equal. The second physics idea is universal gravitation, which is g times mass of component 1 times mass of component 2 divided by the radius squared. And as well as the position and velocity update formulas, which are used, as well as Newton's second law, which states that force equals mass times acceleration and momentum equals mass times velocity. So the reasoning for using these formulas was in part 1, the parallel and perpendicular components were used to find the mass of the black hole, as well as Newton's second law was used to set up the equations to be put into these component equations. In part 2, universal gravitation was used and as well as the update formulas to create the trajectory of the ship itself. The system was the black hole and the surroundings were the star, ship, and moon. The initial conditions are shown here. For part 1 of the lab, these were the initial conditions, and the part 2, these are the initial conditions. My Georgia Tech email was input into part 1 in order to find the value of the black hole, or the mass. So this was code 1. The initial and final velocities were found, and those values were used to find the initial and final momentum. As from there, using final minus initial for both components, delta V and delta P were found. dp dt was delta P divided by delta T, and F-net equals dp dt, as I said before when explaining the equations. From there on out, multiple equations were used to find the parallel F-net as well as the perpendicular F-net and the dp dt perpendicular and parallel dp dt. From there, the mass of the black hole was calculated through universal gravitation formula. And this is the visualization and graph initialization code that was used to create this lovely diagram. The result of this was 470 data points, which averaged to 8.71 times 10 to the 33 kilograms mass of the black hole. This is the code to part 2 code. Here, the universal gravitational formula was used primarily to find the the force of the planet on the moon, as well as the force of the ship on the moon, as well as the force of the planet on the ship and force of the moon on the ship, in order to create this trajectory. From there, the position and velocity update formulas were used both on the moon as well as on the ship, and this trajectory is found where the ship was launched from the moon and it was influenced by the moon and the star in the center, and it didn't crash into any of the data points at all, and it successfully launched from the moon. This is the visualization graph initialization code. So what does this mean? The rate of change of momentum and its perpendicular and parallel components are the same as the net force and its perpendicular and parallel components, and each of the components summed together equal to the net force. For the what-if question, the computational model would need to include forces for each of the elements. One dominant interaction with the black hole because of its extraordinarily large mass relative to the other components in the system. in conclusion, the similarities of this lab was that the mass of the black hole stayed around a specific value in part 1, which led to a pretty consistent mass. The differences was that in part 2 code, the code did not do a figure 8 as that was not attainable. In conclusion, the mass of the black hole is 8.71 times 10 to the 33 kilograms, and some errors in this lab were coding.